the last class I explained H parameter model and approximate H model. In today's session, I am going to teach the topic of RE model.
Today you will see the RE model. But today is the World Youth Skills Day. So you know very well, Happy Youth Skills Day, my dear students. But if any students are willing to take the admission in IMS GATE Academy, you will get the flat 30% off on selected GATE 2024 courses. But this is the offer is valid for 15th and 16th July, these 2 days only. The students who wants to take admission can make a call to the given numbers here now. These are the numbers are given. You can make a call and immediately you can take the admission. You will get this offer. Understand my point now? 30% off is possible. The students who are going to take the admission today and tomorrow, don't miss it. Understand? Yes, we can start the subject now. Now, I would like to start RE model. I want to start RE model. RE model. This is one of the important model. In the GATE exam or even in the PSUs, this model will be maximum useful. You can expect the questions by using this model. I said already there are 4 models. One is nothing but the H parameter model I said. Second is nothing but the RE approximate H model I said. And third one is nothing but RE model. The fourth one is nothing but the RPi model. But in today's discussion, I will do only RE model. But in the GATE exam, you will not specify by using the RE model, you tackle this question. No. But even if you are very good in RE model, you can apply. If you are familiar with the RPi model, you can apply. Any one of the model you can apply. These 2 models are for finding the approximate values of current gain or voltage gain or input impedance or output impedance. Understand my point now? Yes, I will start the RE model now. But already I explained how to draw approximate H model by using for the given network. By using the same circuit, we are going to do the questions only here now with a slight change only now. What is that change I will give now? There are different types of the circuits you can find in the problems. This I want to take it as a type 1. This is nothing but the type 1 model. There are different types. Those types, if you followed, any problem you can do, any problem, very easily, understand now. Type 1 means the network will be given in this way. There is a transistor here connected with RC, here connected with VCC. DC supply is connected here now. Here connected with emitter resistance RE and also connected with capacitor CE. This is connected with voltage divider biasing R1 and R2. Here connected with one capacitor with AC supply, that is VI. This is connected like this. You can connect to the ground. Here there is a capacitor and output is taken across these terminals. Even you connected here, the load is not a problem. With load or without load also we can do that. But how we can find that gain, input impedance and output impedance, and also the gain I will explain now. But mostly we'll ask the what now, voltage gain only in the GATE exam. That's why I will explain voltage gain, that is enough. I will give idea for the input and output impedances also. Initially, we need to draw AC equivalent circuit. AC equivalent circuit. AC equivalent circuit is more important. Without drawing this network, we can't do anything. How we can draw? There are certain conditions. To draw the AC equivalent circuit, wherever DC voltage source is given, that must be shorted. Directly you can short circuit wherever you are given the DC supply. What DC supply is connected here? VCC is given as a DC supply, that must be shorted. That is the first point. Sir, in case any current source is given, what I need to do? That must be open circuited. Any DC current source is connected in the network, you must open circuit. Next point. Wherever capacitor is connected, that must be shorted in small signal amplifiers. That means these are two capacitors are, 1, 2, 3 capacitors are connected, those 3 must be shorted only directly. We can do. The VI is connected to the ground. These are all connected to the ground only now. All these are connected to the ground. VI is connected to the ground. Yes, I will connect VI to the ground. This VI is connected to the ground. I said wherever the DC source is given, that must be what I said, short circuited. I said now. This must be shorted. This is VI. This is VI, I said. Next, this capacitor must be shorted. Yes, I shorted. This R1 is connected to the ground, R1 to the ground, R2 also connected to the ground. If R1 is to the connected to the ground and R2 is connected to the ground, means those two are connected in parallel or series. You tell me how they will be connected. They will be connected in parallel. These R1 and R2 will be in parallel. R1 to the ground, R2 to the ground, both are in parallel. But I want to take equivalent circuit directly. Equivalent resistance I want to connect now. That is nothing but the RB, base resistance I want to take. By using R1 and R2, I got RB. Sir, what is that RB? The RB is nothing but parallel connection of R1 and R2. I can write R1, R2 by R1 plus R2. From these two values, I will get the what now? This value. Understand my point now? Next one, there is a transistor. Wherever transistor is connected, that's my point. Wherever transistor is connected in RE model, you connect network like this. Already in the approximate H model, I connected one resistance and also one current source I gave it. The same must be connected here now. Wherever the transistor is connected, equivalent circuit you draw like this now. That means the transistor you got, you connect with a resistor. Sir, what is that resistance means? The resistance which is existing between this base and emitter. Base and emitter. That base and, but that means this is just like what this is a NPN transistor, NPN. Just like a PN junction diode, base to emitter can act as a what na PN junction diode. The PN junction diode under AC analysis can have the dynamic resistance. That dynamic resistance I can connect as a what now RE. This can be taken as a RE value. I wish to take this as a RE, emitter resistance. Followed or not? This is NPN transistor, P2N. It is acting just like a PN junction diode. Under AC analysis, that can, its equivalent value, I can take it as a emitter resistance only now, RE. And there is a current source. How the change will come still? For the time being, it is a RE I have taken. If it is taken RE, what current will pass across this that current, we can take it as I generally. Please watch what happens. Next, finally, that I am going to convert into the RB. How I will convert into RB, you watch it now. What I am doing, you watch. Because the full clarity purpose, I am explaining these steps. This current passing through this PN junction diode is an emitter current only now. That current we can put small letters, we can use, best, still good. Because it is a AC analysis only, is it not? No, that's why. So I am taking this is nothing but the emitter current, for example. This point is nothing but the base. Which point? This is the base. Must be base current only required. IB is required. You know very well, just watching this circuit, what you can understand, IB equal to IE form we got here now. But we cannot find base current and emitter currents are equal in the network only now. That is why in the RE model, what they will do, that resistance is a RE, but IE is nothing but you know very well. IE is nothing but what I can write 1 plus beta times of IB, you know very well. 1 plus beta times of IB is possible. The point what you have to remember, beta is a very large as compared to 1. In that case, that 1 can be neglected. If I neglected, I is approximately equal to what I can get, beta into IB, I can get here now. Catch my point. Once this current is maintained as a IB, I need to have this current also same IB only now. If I want to get the IB, IE equal to, I can write IB into beta. IE is nothing but IB into beta. What I did, slight change I made here again. I removed this IE, understanding purpose I am giving these steps. Otherwise directly I can write this step. This I have taken IB. IB if it is taken, what I will get? IE equal to beta into IB. Beta is not taken here now. That beta I would like to multiply to this beta RE. Catch my point. If it is IE, IE into RE is nothing but a drop across this. IE into RE only possible. IE into RE equal to what you can write? IE equal to beta into IB into RE. Beta into, here also same we are getting beta into IB into RE. Same we are getting here. Now what now? The students followed very good. Suppose any student said, I am not getting the clear clarity, sir. Okay, no problem. You maintain this is IB, you put it, wherever the resistance you got, directly you put beta into RE. Sir, strictly I want to understand, sir. Exactly that resistance is the RE, but across that RE, it can flow the IE. But once this current is IB, means same IB must pass. In that case, I have taken what now? That beta I multiplied with what now? This RE, and IE I converted into IB. Then exactly drop will be same only now. Beta into IB, I am going to get that beta into IB equal to IE only available finally. IB into beta. Okay, anyhow, that we can take now. But this side we can have the current source. That current source I can put like this now. This is nothing but the current source. All right, directly one resistor, wherever the transistor is given, one resistance and current source you connect. That resistance beta into RE. This current source, this current depends upon, catch my point. This current depends upon this base current. IC equal to, we know, this current is IC equal to beta into IB, I can write. It depends upon the current, beta into IB, it depends upon IB. And here, RC is connected to the ground. Yes, I can draw RC to the ground. I connected RC to the ground. Understand my point? I am removing this for the timing. RC to the ground I connected. Capacitor is shorted and I can receive the V0 here now. Here, capacitor is shorted. Whenever the capacitor is shorted, 0 resistance here now. 0 into RE by 0 plus RE 0. It is just shorted means directly I can connect this to the ground only now. Capacitor is shorted. Whenever the capacitor is shorted, that I can connect to the what now? Ground. There is no importance of RE. Otherwise, RE is connected to the what now? Parallel connection of this short circuit only now. It becomes 0 only now. I got this network finally. This is AC equivalent of circuit, no doubt. But my aim is to find the what now? Z naught, Zi. If anybody wants to get the Zi, they can watch this side. Input impedance available directly here. What is the input impedance of this network? This is the small AC equivalent circuit only now. Zi is nothing but RB parallel to beta into RE. RB into beta into RE by RB plus beta into RE I can put here now. These two are in parallel. RB into beta into RE by RB plus beta into RE I can use. By using this formula, you can get the what now Zi value. Such a way we can find. And one more point what you have to remember here now, how to find out the what now. But what about these REs are? RE is nothing but the emitter resistance we are saying. Emitter side we got the resistance. That is calculated by, that RE is calculated by thermal equivalent of voltage divided by IE. IE is required under DC analysis only. You need to find the emitter current under DC analysis from the given circuit. When you are applying the DC analysis, what you will do? Wherever the capacitor is given, that is open circuited. Wherever the AC voltage source you got, that is will be short circuited only. The rest of circuit you will take, you will determine the IE value. Understand now? Already you have done biasing of the transistors. There we calculated IE value. The same methodology we can apply to find out this IE one. Understand my point now? Anyhow, that way we can do that now. And what about the output impedance R? Yes, very good. If you wish to find the Z naught, when the view is made this side, you are going to get the output impedance. When the view is made means what I said already, under AC analysis, to find out the output impedance, what you must do? Wherever input voltage source is given, that must be shorted. Wherever input voltage source is given, that must be shorted only now. When and output must be connected with a source. Here the source, one source we are going to connect only now. Whenever this input voltage source is shorted, we don't have any voltage source at the input. If there is no voltage source at the input, the base current becomes zero only now. When base current is zero, this total current becomes zero. Whenever this current is zero, this can act as an open circuit only. Still, what is still left in the network? What resistance is left? Only RC only left only. That is why we can write directly. This Z naught is calculated by, that's my point, Z naught is calculated by RC value only. In case any load is connected here now, any load RL is connected here, load is taken, across the load we have taken V naught. The load is connected, that will be connected to the ground only now. RC parallel to RL is available. Already you have done in the last class in approximate H model now. Z naught is calculated by RC into RL by RC plus RL if the load is connected. The load is not given, only RC is existing, Z naught equal to RC I can put directly. But the next one is to find the voltage gain. What way we can find the, to find voltage gain. The voltage gain is given a symbol of A suffix V. This is more and more important. The questions you can expect from this voltage gain only now. That means when you are finding in any paper, the question in this form, the circuit is given in this form. RE parallel to CE is connected. Below this emitter you watch. RE connected to the parallel to CE. Directly you can apply these formulas only now. RE parallel to CE. If it is connected, directly you can apply formula. But how to find out the voltage gain? Initially, I wish to find what is V naught. Initially, I wish to find what is V naught. What is V naught here? Voltage across this RC. Voltage across this RC means what current is passing through this RC? Beta into IB. That current is passing in reverse. Reverse means load has to, RC has to receive the current only now, but given direction in opposite direction. So minus of beta into IB into RC is nothing but the output voltage I can get. I can write directly V naught is nothing but minus beta into IB. This current is passing across this RC into RC value only now. Into RC. Once you got that base current, you can determine the gain, voltage gain. Voltage gain is nothing but output voltage by input voltage. This is nothing but V naught by Vi is to be taken here now. How I will take, you watch here now. But IB is nothing but these are all connected in parallel. When these are all connected in parallel, voltage across this beta into Re is nothing but Vi itself. This is Vi only. So IB is nothing but Vi divided by base current IB. I can write this base current is nothing but Vi by beta into Re. I can write directly now. So I can write here now. I can substitute this value here now. V naught equal to, I can write minus beta into IB is nothing but a Vi divided by beta into Re into Rc. That I can put directly. But a beta here I can cancel. I want voltage gain. Voltage gain is nothing but V naught by Vi. I can use this formula. Beta cancel means minus Rc by Re I can get. The students must remember this formula. Sir, I will not remember formula, sir. Yes, do you derive it? You must derive. You'll get, it doesn't take more time to get that answer, what that formula. Once you got this formula, directly you can use now. That means Rc parallel to Re parallel to C is given, means voltage gain can be calculated by minus Rc by Re. Re is nothing but Vt by IE. Vt you know very well, thermal equivalent of voltage at room temperature is nothing but 26 millivolts, we can take it now. IE you need to calculate by using DC analysis only from the given circuit only now. That way you can determine the parameters of these only now. This is case 1. Now I think every student followed the way of finding the voltage gain or input impedance or output impedance only now. Understand now. But I will give the one more type. Type 1 I gave it now. I will enter into the type 2. Type 2. Type 2 I want to plot. But in before that, very starting itself I gave it now, because the Youth Skills Day, World Youth Skill Day, 30% off is given on selected GATE 2024 courses. The students who are willing to take the admission in IMS GATE Academy can make a call to this number and they can get the 30% off in their GATE 2024 course only. Yes, now I can go to the type number 2. The students can understand clearly. Type 2. This network of the form like this. There is Rc. This is VCC. This is directly connected to the ground. Emitter is directly connected to the ground. But here connected with resistors R1 and R2. There is a capacitor and connected with a voltage source Vi. Even you connected all these, no problem. Even you left as is, no problem. There is a capacitor with V naught only now. This is type 2. I said already in type 1, emitter resistance is parallel to this CE. In type 2, the emitter is directly connected to the ground. Emitter is directly connected to the ground. But here, you draw the AC equivalent circuit, I asked. If I ask to draw the AC equivalent circuit, what you will do? you can do now like this now. We can draw AC equivalent circuit in this way. AC equivalent circuit is required. How we can draw this network? If input is the AC supply, wherever the DC supply is given, that must be shorted, I said. You can short. Wherever capacitor is given, that must be shorted. AC input is to be taken as T. This is connected to the AC supply must be taken. DC voltage is shorted. This voltage I can note down as a VI. This is VI. And here R1 is connected to the ground and R2 is connected to the ground. Both are in parallel. When they are in parallel, I said already, we will get a equivalent resistance of RB. Sir, what is this RB? Sir means I said already, if R1 and R2 are in parallel, you will get equivalent resistance of RB. RB is nothing but R1, R2 by R1 plus R2 I can write. The equivalent resistance you can get. Wherever transistor is given, there you must draw an equivalent circuit, I said now. How that equivalent circuit is to be drawn? You need to put one resistor that must be connected like this with one more current source. The value of that resistance is given already, beta into Re, same. This current is the base current, same base current is going to flow. This current depends upon this base current because IC equal to what? Na, beta into IB. This current IC I can get from beta into IB. Small b I can use. Beta into IB I can write. And here this emitter is connected to the ground. Yes, I can connect to the ground. The RC is connected to the ground. Yes, I can connect this to the ground. And capacitor is shorted, I can get the V0 only now. These are all grounded, you can combine by line. I am getting this circuit. So every student can identify one point. The circuit, whatever you are getting in the type 1 AC equivalent circuit, whatever you are getting in type 1 is same in type 2 also. That means even RE is connected parallel to the CE, even emitter is directly connected to the ground. The formulas available are same only now. Equivalent circuit already we are getting now. When the view is made this side, I said already ZI is available. I said already RB parallel to beta into RE, this into this by this plus this. When the view is made this side means Z0 is available. That formula also given directly. But the voltage gain is anyhow important, so that I will put here now. Voltage gain can be calculated by same formula, whatever I gave it now, because same circuit only, already given you watch. The same circuit only. What is the voltage gain? Minus RC by RE only. Minus RC by RE I can use. Minus RC by small re I can do. Small re. Where re equal to already given. Re emitter resistance equal to thermal equivalent of voltage by IE under DC analysis is required. So these are the rules are already given. It is not an extra rule. The same rules what you explained before. Name only we given type 2. Why I gave type 2 means the circuit with some changes there now. But the formulas will be same only now. Understand now. This is type 2. One more type is there, I will give now. Type 3, I will give now. Type 4, I want to give in your hand. You must make an effort to get its answer only now. Understand now. Type 3, I will give now. Type 3. What is next type? In this model, you cannot find any bypass capacitor to the emitter resistance. Now, RE is not connected parallel to the CE. At the time, what way we can find the voltage gain is more important. Just I will explain the voltage gain because that is important. Suppose you are given network in this form. here connected with RC. There is VCC. Now directly you can use the formulas. I will give the certain problems also. Easily you can tackle. There is RE. This is connected to the ground. I am not connecting any bypass capacitor for this RE. There is a capacitor with capacitor is connected and V0 is taken this side. And here connected with R1 and R2. This is R1, this is R2. There is a capacitor with AC supply VI is connected here now. This is the given network. Check it, how the formulas, how the circuits are differed. In type 1, once again I am repeating, in type 1, RE is connected parallel to the CE. In type 2, we connected only what now? It is not connected anything now. The emitter is directly connected to the ground only now. Type 3, only RE is connected. There is no bypass capacitor. What way we can find the voltage gain? We need to draw AC equivalent circuit for this. Once you have drawn the AC equivalent circuit, easily you can determine input impedance or output impedance or voltage gain or whatever it may be. I want to get AC equivalent circuits. How we can draw? Wherever the DC supply is given, that must be shorted. I said, you short circuit directly. Wherever capacitors are given, they must be shorted, I said. AC voltage source is to be taken as it is. AC voltage source must be taken as it is. This is connected to the ground. We can connect. This is shorted. When this is shorted here now, connected to the ground, R1 to the ground, R2 to the ground, both are in parallel, then I can get one base resistance. That I wish to take it as a RB. Already I said how to get RB. RB I can get from R1, R2 by R1 plus R2 I said. There is a transistor. The equivalent circuit for the transistor we can plot in this way. There is a resistor with a current source is must. That resistance I gave beta into RE. This is IB. Even this current also same IB now. But emitter is connected to RE. Here I can connect to the RE. That's connected to the RE. This current source depends upon base current IB. I can write beta into IB. IC equal to beta into IB I can write. RC is connected to the ground. Yes, I will connect RC to the ground. This is RC. Next, the capacitor must be shorted, then you will receive the output V0. If capacitor is shorted, I can get the V0 this side. If you want to combine means this ground and ground, you can combine this ground and this ground. Sir, I will not draw. Okay, leave it, no problem. This current is IB, this current is beta into IB, this is IE, emitter current IE. IE equal to IB plus beta into IB. If IB is taken common, 1 plus beta times of IB I can get. 1 plus beta times of IB I can get. But input impedance means directly you can find input voltage by input current. You will get directly. Understand my point now. But anyhow, I will find the what now? Voltage gain only now. Understanding purpose. How to find voltage gain? V0 is nothing but voltage across this RC. What current is passing across RC? Beta into IB passes. The direction of this current is taken in reverse. That's why I can take minus beta into IB. I can write V0 equal to minus beta into, what I can write? Beta into IB into RC I can write. But I want to find what is IB. How I can find IB? If this voltage is a VI, this voltage is also same VI, I can put. This voltage is taken VI only now. I want base currents. These two voltages same only. If I apply the KVL in this direction, I can measure the IB value. I must apply KVL. VI equal to drop across this plus drop across this. How I can take? Please watch. According to the KVL, VI equal to beta into RE. I can write beta into RE plus into IB. Beta into RE into IB. When I go this side, some drop. 1 plus beta times of IB into RE. IB into RE I can write. But I am in need of IB. Base current is required. That base current I can get like this. VI divided by beta into RE plus 1 plus beta times of RE I can write. 1 plus beta times of RE. 1 plus beta times of RE. IB is taken common. Now, still if you want, you can simplify. Still, if you want, you can simplify. 1 is very small as compared to the beta. Beta is a very large, 99, 100, 80 or something they will give. At the time, what I can write, beta is far more greater than 1. Anyhow, the voltage gain is an approximate value. RE model can give approximate value of input impedance or output impedance or otherwise voltage gain or whatever it may be. So it is an approximate. That is why approximate value required means I can neglect 1, no problem. And finally, I can write base current equal to what? VI divided by beta into RE plus beta into RE I can write. I can write. If beta is taken common, what I will get? VI by, what I get the VI? VI by the beta is taken common, RE plus capital RE I can write. That I am getting here now. But here, suppose RE is a very large. Mostly you will find emitter resistance is large. RE is a very small. The resistance across the what now? The P-type and N-type material. In NPN transistor, between P and N, what resistance? But the AC equivalent resistance is nothing but the RE. That comes very smaller only now. That's why what I can say, practically RE is very, very large as compared to small RE. Very, very large as compared to small RE. At the time, I can neglect this RE, small RE, I can neglect. If I neglected, what base current I can get here? I will get base current like this only now. I will get base current like this. The base current equal to, I can get VI by beta into, what I will get? Beta into capital RE. Small RE is neglected, capital RE is available. Beta into capital RE again. So by using this IB, I can measure voltage gain. We got already what is V0 is given. Output voltage is given already. What output voltage is given in this problem? They are given V0 minus beta into IB. Beta into IB into what I gave it? Beta into IB into RC I gave it. Into RC I gave it. There I can substitute IB value. So I say V0 is nothing but minus beta into IB is nothing but VI by beta into RE into RC I can write. There I can cancel beta beta. I want to find what is V0 by VI. This is the required voltage gain. This is nothing but beta beta cancel means minus RC by RE. But RC will be given in the network, RE will be given in the networks. Directly you can determine voltage gain. These are the 3 models I would like to give in this session only now. Understand now. But in the first model, RE is parallel to the CE. There I am getting voltage gain equal to minus RC by small RE. In the second model, the emitter is directly connected to the ground. Formulas are same I said now. In third case, RE is connected, but there is no bypass capacitor. In that case, voltage gain we can get from the formula minus RC by RE only now. And one of the question I want to give in your hand, you try to do. There's a type number 4, you can take it now. Understand my point now? You can do without my help. I will not, just I will give the what no network. You try to get answer. Just for practice I am giving. I am asking find output impedance. Find Z0 I am asking. Find Z0. Using RE model only I want. Here I am giving understanding purpose I am giving. Using RE model you get it. Using RE model. I am giving here network like this now. You can try. This is connected to the VCC. Here emitter resistance is connected here. There is no RC in this network. That change is there now. But output I received across this V0. Here I connected with R1 and also I connected with R2. This is R1. This is R2. There is a bypass capacitor. There is a capacitor, sorry. There is a capacitor. This is connected with AC supply. This is VI. I am asking you find output impedance for the given network. Z0 I want. You make an effort to get answer for this question. Now I will do certain numerical problems by using the analysis I gave today. Understand now? Analysis I did something there now. Using that analysis we can do, understand my point now? Yes, we can do now. And before entering into the problem, just you watch the what now this slide. But I am repeating number of times. Today is the Youth Skills Day. The students who are willing to take the admission in IMS GATE Academy can get the flat 30% off. This is available, this off is available only for the 2 days, 15th and 16th. Those who are willing to take the admission in IMS GATE Academy, they can make a call to this number and they can take the admission. 100% they are going to get that much percentage of off. Don't miss it. If anybody wants to take admission, just call to these numbers. Now we can do the certain number of the problems based upon the conditions I derived. Yes, I will give the problem now. Now the students will not face any problem. Whenever you did 1 or 2 problems, you will get idea. 100% easily you can do any problem in any competitive exam. The problem is given like this. BJT has beta equal to 100. Beta equal to 100. VBE equal to 0.7 volts. Base to emitter voltage is given 0.7 volts. Base to emitter voltage is given 0.7 volts. Find AV. Is asking to find voltage gain AV. Voltage gain is required. And here the network is given like this. Transistor with RC equal to 5K. 5K resistance is connected here. And supply voltage is given 15 volts, 15. The emitter is connected to 1.4K resistance here. 1.4K resistance. And there is a bypass capacitor CE. There is a bypass capacitor CE connected one capacitor, and V0 is taken across the load also connected. That RL is given here, that RL is given as 6K. That's given 6K. And here voltage divider biasing is made. The R1 is with 80K and R2 is given with 20K. This is 20K. There is a capacitor with VI. But is asking to find voltage gain AV from the given network. How we can find this voltage gain? Please watch it. This is the given problem. What way we can do? But once you know the formula for the given network, if you identify the type, then you can understand what formula you need to use. If you know the formula, you don't need to draw AC equivalent circuit. Directly you can apply that formula. I derived already. When RE is parallel to CE, directly you can find voltage gain. You can find voltage gain by using this formula. Minus RC. RC when applicable, only RC is connected here. But RC and RL are connected in parallel here now. I said already, output is nothing but the what now? Z0 equal to RC I gave it. Here I got what now? Z0 equal to I am getting here RC RL by RC plus RL is possible. Because this is ground will come. Those two are in parallel, I explained already. Okay, anyhow, this is the formula what I can in the place of RC by small re, I will use Z0 by small re. I have taken Z0 equal to RC only before. That's why RC by RE. But the Z0 is nothing but RC RL by RC plus RL. Then you are given RL. That formula is applicable. Initially, RE is required. RE can be calculated by the formula I gave already. Thermal equivalent of voltage by emitter current under DC analysis only. Under DC analysis, what you have to do, wherever AC voltage source is given, that is shorted. Wherever capacitor is given, that must be open circuited now. Then the equivalent circuit I can get in this way under DC analysis. There is 5K resistor and also connected with 15 volts. Capacitor is open circuited. Under DC analysis, this is a 1.4K I can have. Here I got 80K this side, and also I got 20K. This is 80K, this is 20K. Under DC analysis, capacitor is open circuited. This network will be removed. Under DC analysis, this is removed. I am getting this network only now. I can say this current is nothing but the base current, emitter current I can say, under DC analysis. But this emitter current also not exact value. It is an approximate value only now. RE model is an approximate value. In this case, base current, because don't write it, I equal to 1 plus beta into IB sir, IB I will calculate sir, that's not required. You need to calculate IB. But when it is possible to find IE without IB means you can find this node voltage, I can take it as a base voltage only. Base voltage. VB is nothing but voltage across 20K. Base current I am neglecting. Base current is a very small, I neglected because approximate methodology only is now. In this case, what is VB? If I ask, anybody can say VB is nothing but, according to voltage divider formula, I can use voltage divider formula. I can write 15 into 20 divided by 20 plus 80, 100 I can write. But I will get 20 pi's, I can cancel. 3 volts I can get. I can get 3 volts only now. But a VB, once you got, you can apply the KVL in this direction. If I apply the KVL, VB equal to drop across this plus drop across this. VB is nothing but 3 volts Base to emitter voltage is given 0.7 volts. The drop across this emitter resistance is 1.4 K. I can write 1.4 K into IE, resistance into current only now. That current I have taken IE. Use calculator, you will get emitter current directly. There is IE DC. Under DC analysis, we are getting that current is taken 1.64 milliamperes. 1.64 milliamperes of current is possible. Without base current, you must find. Here now, IE equal to 1.64 milliamperes. Once you got the emitter current, you can determine RE value. So I can say RE is nothing but thermal equivalent of voltage divided by IE. We know very well. BT is nothing but 26 milli. And we got IE. Emitter current just now I got. What I got already? That I is 1.64 milli. If you use calculator, that RE comes as 15.85. 15.85 ohms, not kilo, not mega, very smaller value. That is the value is possible. Once you got this RE, you can determine voltage gain. But in the network you watch, RE parallel to CE. You can apply Z0 by RE. The Z0 by RE I want. But they required what is Z0 also. Z0 equal to, I gave it RC parallel to RL. But in a problem it is given RC value I gave already now. That RC is given as a 5K. And parallel to the RL, load resistance is given 6K. This is 6K it is given. Divided by 5 plus 6, 11K is possible. When you are using the calculator, you will get Z0 equal to 2.4K is possible. 2.4K is possible. But using this Z0, I can find now voltage gain AB. AB is nothing but minus Z0, 2.4K divided by RE. RE is nothing but 15.85. 15.85 is possible. That is the voltage gain is possible. But its value will be minus 151.4 is mostly possible. That much voltage gain is possible. But I think every student might have followed the way of doing this question. But direct formula application only, nothing more than that. Understand my point now? And one more question I will do here now. You will get some idea. Before going to the what now? Problems. Just go through this slide at first. Just go through the slide. The students who wish to take the admission in IMS GATE Academy can go through it. The who wants to take the admission in IMS GATE Academy, for the GATE, there is a 30% off because the Youth Skills Day. This is only for 2 days, 15th and 16th July. Don't miss it. Yes, I will give you one more question. Easily you can understand now. Are you ready to do the next question? Yes, we can do now. Yes, I will give the question now. Find AB. is asking to find voltage gain for find AV for the network given like this. This is RC, this is 1K. Supply voltage is given 20 volts. Emitter is connected to the ground and beta is given 100. 300K resistance is connected here. 300K resistance. This is connected to the VI. This is one more model. We need to find voltage gain for this. How we can find this voltage gain AV? How we can find voltage gain AV? But how you can understand whether it is applicable or not applicable? This is RE model. In RE model, you will give one parameter only. Beta value will be given. Beta is nothing but HFE, forward current gain will be given. If all 4 H parameters are given, I did the model. If only 2 parameters HFE and HIE and HIE and HFE are given, approximate H model. Only beta is given, it is a HFE. You can apply this model. So, what model? RE model you can apply. But is asking to find the voltage gain. How we can find the voltage gain? Is a type number 2. Why it is a type 2, sir? Emitter is directly connected to the ground. If emitter is directly connected to the ground, you will apply. What model you will apply? What now? Type number 2 and type 1 are same only now. Those 2 formulas will be same only now. The formula you applied for the type 1 and type 2 are going to remain same only now. But here I will put here now voltage gain is nothing but I want to take output across this, that must be given. That's given. Output is taken here now. And here I can say the voltage gain is nothing but minus RC by small re only. Type 2 it is, emitter is connected to the ground. But the formulas in type 1 and type 2 are same, I gave it already. But RE I can get only if I know IE value. Without RE, I can't do this question. VT by IE under DC analysis. But these two, but R1 and R2 are given means I can find VB value. In the last problem I have done. By using VB, I can get IE value. But here I don't have any R2. This is a fixed biasing is given this side. The fixed biasing is given, you need to find IB. Without IB, we can't get IE. Must, you need to find IB value. Under DC analysis, I can say, under DC analysis, wherever input voltage source is given, that must be open circuited. That must be shorted. Input voltage must be shorted. There is a capacitor, sorry, I have forgotten to you. There is a capacitor. Wherever capacitor is given, that must be open circuited. And finally, I can get this is RC, this is a 1K, this is a 20 volts, and here connected with one resistance. That resistance is 300K. But IE I can get only if I know IB. Here IB is a must. If the voltage divider biasing is given, you think it's so, I can get VB value. Here I cannot get VB only now. That's what is a must. What is must? This value is required. What IB is a must. IB is nothing but I can write 20 voltage minus this voltage is 0.7 voltage VBE, you know, divide by 300K. Its value will be 0.09096 5 milliampere, 0.965 milliamperes. That much current is possible. 0.0965 milliamperes possible. By using this base current, you can find what is IE. IE equal to, we know very well, 1 plus beta times of IB. This is a fixed biasing. In the fixed biasing, you must find IB. Without IB, I can't get it now. If it is a voltage divider biasing circuit, directly VB you can get, then you can apply the KVL, you can determine IE as given in the last problem. Here 1 plus beta, beta is nothing but, how much it is given? 100. IB is nothing but 0.0965 milli 10 power minus 3. Use calculator, you will get IE. That IE value will be 9.74 milliamperes. 74 milliamperes of current is possible. That much amount of IE is possible. By using this IE, I can determine RE value. RE is nothing but VT by, I said, IE. The VT is nothing but 26 millivolts divided by IE is nothing but 9.74 milliamperes. Its value will be 2.66 ohms. 2.66 ohms it is possible. 2.66 ohms possible here now. Once you got this RE value, you can find the voltage gain. What is the voltage gain you can apply? AV equal to minus RC by RE. RC is given, RC equal to 1K is given here. RC equal to 1K. RE is nothing but 2.66 ohms. 2.66 ohms. So use calculator. Then voltage gain you will get as minus 375. Minus 375. That much amount of voltage gain you can get. But I think the students might have followed the models what I explained. But try to go through these videos, this video. If you don't understand anything, then you will get the clear clarity on it. Understand now. Okay then. Thank you very much. I think so far you followed very well.